So we come to our cell below hand, equals average, right? Parenthesis, go ahead and highlight. Highlight it. All right, so we highlighted everything. Okay.
Don't worry, this first part is actually okay.
I didn't see anything.
Yeah, okay. All right, so we have our years of education here, right? So we need to find our mean year of education first, all right? So we go to this cell, equals average, right? Parenthesis. Then we can highlight all our years of education, close it, hit enter. Our average number of education years is 13.71. All right. The next thing we need to do is we need to calculate our standard deviation. So we just work on the cell below that. All right. So it's equals STDEV. All right. Parentheses. Highlight your variables of education. Close it. Make sure you do not grab your mean that you already calculated, all right? So now we have those two numbers. Our first step here, okay, so we highlight here, equals, all right, we want to take this value minus our mean, all right, so that's 13.71. All right, make sure you type it in. Do not click on the cell.
Okay.
It'll screw everything up. All right. Oh, you don't need to do that. Click enter. Okay. So by subtracting the mean, we got a negative 3.71. All right. So if we want to copy that formula all the way down, once we click on this, we come to this green square, drag it down, and it does that formula for all those cells, all right? So that's our first step. Our next step, we come over here, all right? Equals this number we just calculated divided by the standard deviation of 3.15. I rounded, okay? Click enter, all right? Come back. Click and drag. These are our z-scores. All right. So, someone with 10 years of education, okay, has negative 1.18 standard deviations of education compared to the mean, right? So that's what this is telling us. Someone that has 18 years or a master's degree has 1.36 standard deviations more education than the mean.
What did you say the standard deviation like represents again?
The standard deviation is like the average distance from the mean, okay? Or the average variation among the data, okay? So we then can use these numbers, okay? So if we want to know how much of the population has 10 years of education or less, all right, we come to our table, all right? So we have negative 0.177, all right? Okay, we draw our normal curve. That's our mean, median, and mode, okay? And so this case, it's 0 standard deviations, and it also represents 13.71 years of education, the mean, okay? So now, negative 1.17, right? So here's negative 1, negative 2. All right, so 1.17 is just a smidge below it, right? So that's where we are, okay? So now if we want to know, so when I ask you a question, I'm gonna be asking you how much of the population has more education or less education than someone that has 10 years, okay? So if I say more, you're gonna wanna tell me the amount of the population to the right.
Okay.
If I say less, you'll wanna tell me the amount of the population to the left, okay? So let's say how much of the population has more education than someone that has a 10-year education, okay? So we know this is our mean, median, and mode, right? Our zero standard deviations, right? Remember, how much of the population is on this half of the graph? If it's exactly half,
50.
50%, right? So 0.5, all right? So we already have that amount, right? So now, if we want to figure out how much of the population has more education, we already have this number. We just need to find this number here, okay? So we come to our table, and we come and find negative 1.17, or 1.17. It's not negative, okay? So 1.17, all right? Here's what we found, all right? So this column next to the z-score is telling us the amount of area between the mean and the z, right? That's what we want, right? The area between the mean and the z, okay? So we come down here, right? So it's 0.379, all right? So that's telling us 3 point, what did I say?
0.379.
379. Right, 0.379. So that means there's 0.379% of the population is in this area. And we add it to this, right?
Okay.
So it would be 0.5 plus 0.379 would equal 0.879. Or if we move that to a percent, right? 879, we move it over 2 places, so it'll be 87.9%.
Okay, cool. So this, again, this minus negative, like this area was because of this number, right? What the mean?
It's just telling us that these years of education are below our mean.
So I can't remember how we like. I don't know how to ask the question. But like the negative one, like the.
I think we have -1 here already,
Right.
so that's where
So-
it's come from.
Yep, because 10 years is below 13.71 years.
Okay.
Okay, so that's why it's negative. If we go here to 16 years, right, let's go to 18 years. Okay, so 18 years is, so that's 1, that's 2, all right? So they're 1.36 standard deviations above, right? 18 is more than 13, right? So if 13 is our average, right, that's why 18 is positive, right? So that's 1.36. That would be here, all right? And then if I wanted to know how much of the population had an education above someone that has 18 years of education, we would go and find 1.36. Okay, where's my 1.36, okay? So if I want to know above, right, I'm finding the area this way, right? So that is from the z-score and beyond, right? So it's this area here,
Okay.
okay? So we come to 1.36. That tells us 0.0869, right? Because it's the area beyond the z that we're interested in, right?
So how you know it's area beyond the Z is because of the distribution, like how you,
because I plotted this area here, right?
Okay.
And then I said above, right? I wanna know how much of the population has education beyond a master's degree, okay? So I'm, in that statement, I'm telling you above, right? So that's why I would know beyond Z, right?
yeah, I was trying to know why you didn't like use this column, but like move to the next.
Right, so let me finish up and then
Okay.
so this is our number, so 0.0869, right? So this is 0.0869 or 8.699% of the population has more education than someone with a master's degree,
Okay.
okay? Now, we'll draw a new one. Alright. So there's our standard deviation, our z-score, right? And then it's also 13.71, right? So with the same value, okay, we're still working with 18, all right? So here's 1, 2, so it's right about there, okay? Now, if I said how much of the population has an education less than a master's degree, you would need to give me all this information here, okay? So we know from here, this is 0.5, right? So now we just need to figure out this area between the z-score and the mean, all right? So then we would come to, again, the same number, 1.36, all right? And the area between the mean and the z is 0.4131.
Is that less than?
Right, because I'm saying less than this point right here, okay? This is someone with 18 years of education.
Yeah, I understand that, but like, to this, the 1.36, so I'm thinking like, you read this way because like, so you're trying to find for this area, right, for this present example, so I'm thinking probably it's gonna be, where's the 1.36, like this number instead.
No, see, it's only,
I think we have the 0.5 already. That's why we're getting in between.
Yeah, but,
right, you know,
oh, so the negative or positive, like however you phrase the question, does not depend on.
right,
So I'm thinking like these are 3 columns, right?
mm-hmm,
So I'm thinking this is how it's in my head. This is the center, which is like 0, and this is the positive and negative.
No.
So that's wrong.
mm-hmm. This is your z-score. This is what we're looking at. We're already working with the z-score,
Okay.
right? So that's why we have to draw this to let us know what area we
Drawing
need to
it.
find,
Okay.
okay? So because I said how much of the population has education less than 18 years, right? We know that this part is already 1/2 or 50% of the population.
Okay.
So we just need to find the area between the mean and the z-score, okay? So we come over here to 1.36 and it's 0.4131. So it's 0.4131. So then we just add that to our 0.5, all right? And that would be 0.9131 or 91.31%.
Cool. The one where you need to like subtract was an alternative if you didn't want to add the 0.5, right? Because once you did like a subtraction with the number.
Yeah, okay, so the way, all right, so here is this, so this number, right? So this is our point, it's the same point as over here, right? So we know the area from our z-score to the beyond, right, is 0.0869. So you could also just, because we know this whole area is 1, right? we could take 1 minus 0.0869, and it's going to give us the same exact number,
Okay,
okay?
okay. Alright. Go practice that, so.
Yes.
Alright, thank you.
Mm-hmm. So like on the exam, I might have a variable here and then another variable, and you'll have to calculate z-scores for this one and this one, and then tell me which ones match.
Match, like
Yeah.
similar numbers,
Right.
but that would be obvious.
Oh, obvious.
If you
Obvious.
know how to calculate it.
It'll be obvious, or that means we'd have to calculate all of them.
Right. So if I give you like 6 or 7 numbers here and 6 or 7 numbers here, and you're allowed to use the computer,
Yeah.
right? So I'm not telling you you have to do it by hand, right? So if you can calculate your z-scores and you get the z-scores and you find out that this number is the same as this number over here, you know, all you need to do is draw a line or something, and it will be obvious as long as you know how to calculate.
Calculate it.
Oh, okay.
I'm not here to trick you, right? I just want to know you know how to calculate z-scores and then how to find the percentage above or below. All right?
Okay. Thank you, sir.
Yep.